Hey students, this is a video in section 9.5 which is about solving formulas. So what are formulas? Formulas are equations that have two or more variables. Oftentimes they have 3 variables or even 4 variables. Okay, so equations. And these are equations usually from the real world. So like in physics, that kind of stuff. Science. Equations from the real world with 2 or more variables. And each variable is going to be represented with a different letter. Sometimes the letters are lowercase, sometimes they're uppercase. Sometimes you may even see Greek letters, although I don't think we have any Greek letters in our class, except for maybe pi. Alright, so equations from the real world with 2 or more variables. And we're going to be working on solving them. So we're going to be plugging in numbers, and then we're also just going to be solving for a specific variable. And this is important because as STEM majors in your science courses, it's important that you be comfortable with solving a formula for a specific variable and also plugging in. Okay, so let's do an example. Okay, example. Substitute the given values into the given formula. Substitute the given values into the given formula. And solve for the unknown variable. And solve for the unknown variable. Okay, and we're going to do a couple of these just to get the hang of it. So for example number 1, our formula is capital S equals 4 times capital L times capital W plus 2 times capital W times capital H. Sorry, I ate some spicy food and I keep harumphing. The smoke outside isn't helping either from the fires. Alright, so our formula is S equals 4LW plus 2WH. And they're telling us that capital L equals 7 and capital W equals 4. So basically what they want you to do here is you plug in these numbers for the variables and then you solve for the unknown variable. Oh, and they also told us that S equals 128. So they gave us one more variable. Capital S equals 128. Alright, so we're just going to be plugging everything in here. So let's start with the S. So we're going to be replacing the S with 128. We're going to be replacing every single L. Well, there's only one L here. We're going to replace that L with 7. And then we're going to replace these 2 W's with 4. So our first step is to just plug that all in. So that's going to give us 128 equals 4 times 7 times 4 plus 2 times 4 times h. We don't know what h is in this problem. They didn't tell us what h is, So h here is going to be the unknown variable. It's the one we have to solve for. Okay? So our goal here is to isolate h. That's what we're shooting for. Because h is the only variable that's left. So that's what we're going to do. So let's start with 4 times 7 is 28. And then what's 28 times 4? You can't do it in your head. You can always use whatever calculator you use. So 4 times 7 is 28. And 28 times 4 is 112. So we've got 112 plus 2 times 4 is 8h on the right side. And on the left side, we have 128. Okay, and we want to isolate h. So to isolate h, the next step is to do our subtraction. So we want to get rid of this 112 on the right side. So we're going to do that by subtracting 112 from both sides. So if I minus 112 from both sides, then on the left side, 8 minus 2 is 6, and 2 minus 1 is 1. Okay, so we actually get 16 on the left side, and then on the right side, now we just have 8h. 8h. Okay, and then to solve for h, we have to get rid of this 8, and the opposite of multiplying by 8 is dividing by 8. So we're going to divide both sides of this equation by 8. So on the left side, 16 divided by 8 is 2. So we get 2 equals h. Okay, so our answer is 2 equals h. 2 equals h, or if you switch the order around, it says h equals 2. Okay, and that's how they want you to write your answer. Now granted, each problem in your homework is going to have a different formula, so there will be different tricks that you're going to use for each of the individual formulas. And I can't do all of the formulas, but I can do some of them for you. And then we'll go, you can practice the other ones on your own in your homework. Okay, so that was problem number 1. Example number 2, our formula is A equals 1/2 times little h times a quantity, capital B plus little b. Okay, and they tell us that capital A equals 35, capital B equals 4, and little b equals 3. Okay, so capital A equals 35, capital B equals 4, and little b equals 3. Notice here there's a difference between capital B and lowercase b. Okay, so first thing is plug everything into the formula. So for A, we're going to be plugging in 35. For capital B, we're going to be plugging in 4. And then for little b, we're going to be plugging in 3. Okay, so plugging that all in, we get 35 equals 1/2 times h times a quantity, 4 plus 3. So there we just plugged everything into the formula. And when you're simplifying these formulas, you do want to use PEMDAS. So here, first we want to do parentheses. Then we'll do our multiplication. So the parentheses here, we have 4 plus 3 is 7. Okay, and then 7 times 1/2 is actually going to give us 7/2. So we're going to have 35 equals 1/2 h times, well, this is actually 7 over 1, right? Because 4 plus 3 is 7. And then 7, if they don't write the denominator is 1. And then how do you multiply fractions? Straight across. So if I move this 7 over 1 over here, and we multiply these fractions straight across, on the top we're going to get 7 times 1 is 7, and on the bottom 1 times 2 is 2. So on the right side here, we're actually going to have 7 halves times h. Okay, so we have 35 equals 7 halves times h. And we still have to isolate h here. So remember, if you're trying to solve an equation with fractions and you want to get rid of the fraction, the trick is you multiply both sides by the reciprocal of that fraction. So the reciprocal of 7 over 2 means you flip it over. So it's going to be 2 over 7. So we're going to multiply both sides by the reciprocal of 7 halves, which is 2 sevenths. And on the left side, remember the 35, when it doesn't have a denominator, it's 35 over 1. Okay, so we're basically just multiplying both sides by the reciprocal, which is 2 sevenths. And then on the right side, the 7s and the 2s cancel. So we just get h. And on the left side, we can simplify a little bit. So we notice we have a 35 here and a 7 down there. So we can divide the top and the bottom by a common factor of 7. So I'm going to divide the 35 on the top and the 7 on the bottom. We're going to divide those both by 7. Okay? So that's going to give us 2 times 35 divided by 7 is 5. So we're going to have 2 times 5 on the top, and then 1 times 1 on the bottom. So that's just going to give us 10 over 1. And 10 over 1 is just 10. Any number over 1 is the number. Okay? So we're actually just going to get h equals 10. Okay. Cool. All right. So I did want to do one more problem that actually involves a special letter called pi. Most of you have probably heard of pi before, but we are going to be using it because it does show up in formulas. So this is going to be example number 3. Example number 3. Here, our formula is capital C equals 2 pi r. Okay? And here they're telling us that capital C equals 50.2. By the way, this is the formula for the circumference of a circle. I haven't been talking about where these formulas came from, but all these formulas are taken from the real world. We're just working with them to get the math down, but these formulas did come from the real world. So this one is the formula for a circumference of a circle with radius r, and c is the circumference. Okay, and then this little letter here is called pi. Okay, so pi is a special Greek letter, and it's even though it's a Greek letter, it actually is representing a number, and the number goes on forever, but we can approximate it as 3.14. So I write pi is approximately equal to 3.14. It actually goes on forever. It's 3.14159, and it keeps going on and on forever. It's actually non-terminating and non-repeating decimal. Okay, but here we're just going to approximate it as 3.14. All right, so let's plug all this stuff in here. So for the c, we're plugging in 50.2, and then for the pi, we're plugging in 3.14. So we're going to get 50.2 equals 2 times 3.14 times r. So here our unknown variable is going to be r, which is actually the radius of a circle. And we want to isolate r. So first off, we're going to want to do our multiplication here. So some of you might be able to do this multiplication in your head. 2 times 3.14 just means we multiply each digit by 2. So 2 times 4 is 8, 2 times 1 is 2, and 2 times 3 is 6. So it actually gives you 6.28. But if you can't do it in your head, you can use a calculator or you can write it out vertically. But that one's not too bad to multiply. Okay, and then the next step is we need to isolate r, and we have to divide both sides by 6.28. Okay, because this is 6.28 times r, and the opposite of multiplying by 6.28 is dividing by 6.28. So I'm going to divide both sides by 6.28. Okay, so now we're just going to have r on the right side. And then in this problem, they told us to round to 1 decimal place. Okay, so it said it in the directions, I just didn't write it down. I forgot to write it down. So it says round to 1 decimal place. And that means round to the nearest tenth. Alright, and I'm going to go ahead and use a calculator for this. So 50.2 divided by 6.28. 50.2 divided by 6.28. That gives me 7.993. Okay, so 7.993. But they want us to round to 1 decimal place, which means to the nearest tenth. So the one that we're looking at is this digit right here, and the next digit is higher than 5, so if it's 5 or more, you increase the score. So instead of being a 9, it's actually going to become a 10, and we carry the 1 over here. Okay, so this is actually going to round to 8.0. Okay, so our radius is approximately equal to 8.0. And I'm writing this notation here, which means that it's approximately equal to it. If it's kind of curvy like that, that means it's not exactly equal to 8, it's approximately 8. Okay? And that was the whole problem. Okay, so cool. So now we're going to be doing some more problems, but for these other problems we're not going to be plugging in numbers, so it's going to be more abstract. But if you're wondering where some of these formulas came from, this one for number 2 I believe is a formula for area. I'm not sure what it's the area of. I think it might be the area of a trapezoid, maybe, something like that, where capital B is one of the bases and little b is the other base, and h is the height. I think that's the area of a trapezoid. And then this other formula we had up here, I know this was a special area of a box of some sort. So this is actually, I think it's the surface area of a special kind of rectangular box, something like that. But all these formulas come from stuff in the real world. We're just learning how to deal with them in terms of math, because you need to be comfortable with them to do well in your science classes as STEM majors. I think pretty much all of you are going to end up taking some kind of science or other, unless you're a math major. But even then, you're still going to be taking science. So we're going to have a new kind of problem here. And in this new kind of problem, rather than plugging in numbers, they're actually going to let us solve the whole formula just in terms of letters. So it's going to be a little bit confusing because there's so many letters to deal with. It's not like you just plug in numbers, but it's not too bad once you get used to it. It's just very abstract. Okay, so example. Solve the formula for the given variable. Okay, so they're going to tell us which variable to solve for, but they're not going to give us any numbers. So we're going to solve everything in terms of variables, which is going to look kind of messy because it's going to have a bunch of letters. And it's very abstract. Okay, so number one, we want to solve V. So capital V equals capital C L T. And they want us to solve it for capital C. Okay? So there's no numbers that we're plugging in, but we're actually having to solve in terms of all these letters. And we want to solve capital V equals CLT for capital C. And I don't remember where this formula came from. I think it might have to do with volume or maybe, yeah, something like that. Volume of a gas. I'm not entirely sure. But anyway, we want to solve for C. So we want to solve for this one. So we want to isolate C. And keep in mind that C times L times T is what this means. CLT means C times L times T. And the opposite of multiplying by LT is dividing by LT. So here we want to actually divide both sides by LT. So that's what we're going to do. We're going to divide both sides by LT. So on the right side, the LTs are going to cancel. And then on the left side, we actually get V over LT. So we get V over LT is equal to C. And they want you to switch the order of the equation around. So we're actually going to write the C first. So we have C equals V over LT. Okay? And that's our answer. So it's kind of harder because there's a lot of letters, but then it's also kind of easier because you don't have to deal with any numbers. So some people actually prefer these. I actually prefer these. I like it better when it's a bunch of letters. But other people get kind of confused when they see so many letters. It can be overwhelming. Okay. But hopefully that's not too bad. So we're going to do some harder ones now. Ones with more variables. Okay, so problem number 2 is capital Q equals capital R plus capital R times lowercase s times lowercase t. And they want us to solve it for t. Okay, so Q equals R plus RST, and we want to solve this for t. So this one's actually going to have a couple of steps here. The one we're trying to isolate is just this little t here. But in order to isolate it, remember when you're solving an equation, you want to do your addition and subtraction first. So here we're going to want to get rid of the R first. So to get rid of this capital R, we're actually going to subtract R from both sides. So that's going to be our first step. So we're going to minus R from both sides. So on the left side we get Q minus R. And then on the right side we have RST. Okay. And we want to isolate T here. So in order to do that, we're going to have to get rid of the RS. So to get rid of the RS, since this is RS times T, the opposite of multiplying by RS is dividing by RS. So we're going to divide both sides of this equation by RS. Sorry, that was my cat knocking my camera out of whack. Okay, hopefully that's working again. That was Max knocking around my camera with his tail. He was running through it. Okay, so anyway, we're going to divide both sides by capital R times lowercase s. And on the right side, the RS's are going to cancel. So on the right side, we just have t. And then on the left side, we have q minus r all over rs. And you want to switch the order around. Okay, so since they asked us to solve for little t actually is going to be on the left side. So I'm going to rewrite it as little t equals q minus r all over rs. And that's how you write your final answer. And notice when I divided both sides by rs, that denominator rs actually applied to the q minus r. Not just the q, not just the minus r, but the whole thing. Okay, so that one's a little bit harder because it has so many variables and a lot going on. Okay, so let's see another one. Okay, example number 3. Capital D equals 1/2 fk, and we want to solve for the variable k. Okay, 1/2 fk, and we want to solve for the variable k. I don't really know where this formula came from, honestly. But I do believe all these formulas come from the real world. They just don't always list them on my math lab where they came from. So the variable we're trying to isolate here is k. So the stuff we have to get rid of is the 1/2 and also the f. Now remember, when you have a fraction like 1/2, the way you get rid of it is you multiply both sides by the reciprocal, which means you flip it over and multiply both sides by 2 over 1. So I'm going to actually multiply both sides by 2 over 1. And remember that d, the denominator, is just 1. So on the left side, we have d over 1 times 2 over 1. Okay, so after we do that, you should have 2d on the left side, and then on the right side, the 2's cancel. So we're just going to be left with f times k. So we have 2d equals fk. All right, and again, we're trying to isolate k, so the last thing we have to get rid of is this f. And the opposite of multiplying by f is dividing by f. So here we want to divide both sides by f. Okay, so that's going to give us 2d over f is equal to k. So k equals 2d over f, switching the order around. All right, and that's our answer. Okay, and I just wanted to do one more example from this section. This next one is pretty challenging, so I wanted to do it just because it's such a complicated looking problem. Okay, so problem number 4, our equation is capital V equals 7 pi Rx plus 2 pi R squared. Okay, so V equals 7 pi Rx plus 2 pi R squared. All right, and they want us to solve this for x. So the big problem with this one is there's so many things going on. There's so many letters, and also numbers as well. But we want to isolate x. Okay, and we only have an x right there. And I believe this formula comes from volume or surface area, where r is the radius, but I'm not quite sure what they're finding the volume of. Okay, so anyway, we want to isolate x. And like I say, you always want to do your addition and subtraction before you do your division or multiplication when you're solving an equation. So here we want to get rid of the 2 pi r squared. So to do that, First, we're going to subtract 2 pi r squared from both sides. Okay, so minus 2 pi r squared from both sides. So on the left side, now we're going to have v minus 2 pi r squared. And then on the right side, we're going to have 7 pi rx. Okay, and I know it looks complicated, but as long as you write everything the way you did in the previous step, it's not so bad once you get used to all the letters. Okay, so what we're trying to isolate here is x. So on the right side, we need to get rid of the 7 pi r. And that's 7 pi r times x. So the opposite of multiplying by 7 pi r is dividing by 7 pi r. So what we're going to do is we're going to divide both sides by 7 pi r. Okay, divide both sides by 7 pi r. Okay, and after we do that, on the left side, we have v minus 2 pi r squared all over 7 pi r. And on the right side, the 7 pi r cancels out and we just get x. So since we just have x on the right side, we're going to go ahead and switch the order around. So we're going to write x on the left side. And so our answer is x equals v minus 2 pi r squared all over 7 pi r. And I know it kind of looks like you could cancel out the r's or the pi's, but you can't really do that because this term doesn't have a pi and it also doesn't have an r. So there's actually nothing you can do to simplify this. So you actually want to leave it that way. Okay? So that's our answer.